I think this thing is on. So, good morning KubeCon. How is everybody doing? Doing okay? That's great. Almost done with the conference. There will be lunch soon. So hopefully everybody's having fun. Does everybody have 3+ t-shirts? Okay, that's good. My name is Mikolaj Pawlikowski. I flew here from London, from our Bloomberg office in London. So that means that my biological clock is roughly 8:45. So if I fall asleep in flight, don't hold this against me. I'm going to talk to you about two friends of mine, Goldpinger and PowerfulSeal, that are hopefully going to become friends of yours too by the end of this talk. So the idea for the next 30 minutes is to first make a bold statement that distributed systems are hard. That's going to be my hypothesis. And then talk about Goldpinger, setting it up, using it, and PowerfulSeal with a quick introduction to chaos engineering for those of you who haven't heard of that, even though I think it's pretty difficult to pass the KubeCon without hearing about it. And then we're going to conclude and have some bonus section with answers that you can use to sell it to your manager. So before all of that, let me just quickly do a shout out to my team back in London. These awesome people make what's called DTP. It's a microservices platform that we built on top of Kubernetes that has some interesting QC features. I'm not going to go into details. We gave a talk 2 years ago on KubeCon, so if you're interested, you can go there. All right, so let's start with a show of hands. Who thinks that distributed systems are easy? All right, that's good. Otherwise, I'll have to stop the talk here. I think they're particularly hard. If you are anything like me and you have a bad day and you go to Google, Uncle Google does provide some solace too. This is a screenshot, 49 million reasons to think that it's difficult. And I'm seeing some confused faces. They're probably confused because it's already an old Chrome UI. That was December last year. If you take a new screenshot, we're already at 87 million results. And it doesn't stop there. That was September. If we took one last week, we're already at 201 million reasons. So don't feel bad. We are all in the same boat. So I don't know what you guys do with your free time in the evenings, but one of my favorite hobbies is to extrapolate completely irrelevant data. So if we do just that in an almost scientific way, on my graph, we can clearly see that we're reaching roughly 4 gazillion reasons soon enough on the x-axis. To strike a slightly more serious pose, though, I like this quote from Lampert. To paraphrase, it's basically saying that you know you're in a distributed system where a computer you didn't know existed messed up your own computer. And that's really the essence of it. I don't think there is a quote that gives more justice to it, because essentially everything is plotting against you, right? The networking is particularly plotting against you all the time, fails, hardware fails, environments diverge, and consistency is either hard or expensive, or both. So the failure really is a matter of when, and it's not an if. And that's probably like the biggest mind shift that one has to take in order to be able to deal with that. So if you are struggling with this when and not an if problem, or you have to convince someone like your manager, hypothetically, here is an example of what you can use. So a good example in this setup for me has 3 criteria. It has to have an abbreviation. It has to have some mental arithmetics that can be done in the head of a person, and it has to fit in 3 bullet points. So this should check all these 3 boxes. So if we take a set of reliable servers, let's say the median time between failure of 10 years, check for the abbreviation, and we take 4,000 of these servers, we are already at averaging more than 1 failure daily, right? Easy arithmetic for your manager, check. And we don't need web scale for that. We don't need Google scale. We just need 4,000 servers to average that. And averages are also quite horrible because that means that we're probably going to have good days and then going to have terrible days where everything goes wrong. So basically the bottom line here is that the fault-tolerant design is inevitable, and I don't think I need to convince anyone of that, even though we have these conversations daily. There's a little link there that I recommend looking at, but I won't spend more time on that. I think we're on the same page. So this is all a little bit gloomy and a little bit depressing, but the good news is that it's a conference, so there should be goodies. And I have two goodies for you, the IP type of goodies, not t-shirts. One of them is called Goldpinger, and the other one is PowerfulSeal. So to give you a little bit of background, PowerfulSeal and Goldpinger are both pieces of software that have been running at Bloomberg here for about 2 years, and they've proved extremely useful. Let's start with Goldpinger. So once upon a time, when we were setting up our Kubernetes and we were all new to that, we had networking issues. And that's how Goldpinger came to life. Goldpinger is my best friend. Like, quite honestly, we bonded so much that if it came to me today and said, listen, it's good time to invest in Bitcoin, I'd be like, okay, Goldpinger, it looks bad, but I'll trust you. I trust you, no questions asked. So Goldpinger does one thing. It basically pings other Goldpingers. So it's going to ask Kubernetes to give them all the pods, and it's going to ping them periodically and provide you with visibility. So the visibility, kind of the thing that you interact probably with the most, is in the form of this UI. This is a small graph. More likely, you're going to see graphs that look more like this. And it basically shows you all possible connections between the nodes. So it's going to call all its neighbors and ask the neighbors to call all their neighbors to produce this complete graph for you. So this is good for debugging, and this is probably one of the screens that I stare at a lot during my days. But probably the more useful and more interesting is that it comes with Prometheus metrics out of the box. So the Prometheus metrics, this thing on the right, the Grafana dashboard, you can actually go ahead and grab it from the repo and kind of drop on your cluster, and also possibility to set up alert manager alerts if you are running on Prometheus, and quite frankly, you should. So setup is quite simple too. It's the matter of a kubectl to apply. The thing on the right is a direct screenshot from the README on the GitHub repo. And that's really all you need to do to get started with that. So we open sourced, we published it as open source literally last week. So it's brand new. It needs a logo. It needs GitHub stars. And I'm going to claim that it can be set up in 3 minutes. So there'll be some caveats to it, but let me actually try to see if I can set it up in 3 minutes while giving a demo, where obviously by definition I can't type. So this is Goldpinger on GitHub. And this is it describes all the steps for building, installation, and this is the YAML that I was talking about. It's a daemon set with a service. I'm going to go ahead and try to see, OK, so this is my Minikube. I ported that on Minikube so that I don't have to rely on the network. And I have checked out the repo with the example on the service accounts. And just so that you can see, this is literally all there is to it. The one interesting bit is probably that I'm injecting a host name as spec a node name, so that in the graphs and metrics I can actually see the real host name, so that it's easier to understand things. But I'm just going to go ahead and apply that. Before that, let me watch the pod so that you can see what's coming up. I'm going to go ahead, apply, create the service, and create a daemon set. And it's already come up. So let me show you the UI. If I go ahead and use my noteboard and restart this, here's my graph. What do you think? Networking in Minikube is quite nice. It's a good graph. It's all green, 100% green nodes, 100% green connections. So let's make it a bit more interesting. So I did cheat a little bit, and I set myself a deployment a deployment that produces basically more Goldpinger pods for you so that I have something to ping. So if I scale that to 10, and I wait for them to actually come up, container creating, they're starting running. And if I refresh this a couple of times, I should be seeing, oh, they're already up. So that's what the graph looks like. You can go ahead, you can click around, you can kind of see what's going on in debugging and see the view from a particular node. And like I mentioned, the metrics are available right here. All right, so that hopefully was less than 3 minutes. Let me go back to the presentation. So like I said, the Goldpinger is now open source. I can go and grab one, and hopefully by the end of this presentation, you're going to have it installed in your clusters. The one thing that I obviously did to make this magic demo happen is that I tweaked my default service account to actually allow Goldpinger to talk to Kube API. And I built my image beforehand. All right, so that was Goldpinger. Let's take a look at the other part of the presentation about chaos engineering. So who hasn't heard of chaos engineering in the audience here? All right, I see exactly 0 hands. So that's good. That means that you've all gone to principleofchaos.org and you've seen the document and you know what it is, right? But just in case some of you haven't raised their hands, I'm going to make it easy and just summarize that in 3 bullet points. So basically the idea is to increase confidence in your distributed system by purposefully introducing failure, and this way being able to detect bugs that other layers of testing haven't caught. And in this mindset, we built PowerfulSeal. So PowerfulSeal is our chaos engineering tool that we have open sourced last year at the version 1.0. Today we have version 2.0. It was initially inspired by Chaos Monkey, then it evolved kind of a life of its own. But the main difference really is that PowerfulSeal is designed to speak Kubernetes. It's kind of Kubernetes native chaos engineering tool. So it's very easy to work with the abstractions that Kubernetes provides. It comes with interactive mode, it comes with YAML scenarios, we're going to look at that. The setup is pretty straightforward. The PowerfulSeal needs to talk to your cloud driver. Currently we support AWS EC2 and OpenStack. It needs to talk to your Kubernetes API, so it needs either probably kubeconfig, and then it needs to be able to execute sudo docker kill on the nodes over SSH. And the reason for that is that if you just do delete pods through Kubernetes, you're kind of giving it head start. And if you crash the processes themselves, then you're kind of testing the whole loop. Because as far as Kubernetes is concerned, it's going to show up as a crash. All right. So then modes. PowerfulSeal, since version 1.0, has developed 4 different modes. And we have label, demo, interactive, and autonomous mode. So in label mode, you kind of start the seal, and then you go ahead to your Kubernetes, and you mark the pods as targets. So these are the things that are available. You mark it as seal/enabled to true to actually enable PowerfulSeal to kill it. And then you have tweaks on things like kill probability or days of the week and start and time to, for example, do it through the weekdays during the work time, which incidentally is the default. So why don't we take a look at that? So I'm back here to my cluster. I have all these Goldpinger nodes running, pods running. So why don't we give them some hard time? One thing is that PowerfulSeal, if you want to test it, out of the box supports Minikube. So we have things like make label. So you can basically just go ahead and do that target on the make file, and it's going to run with defaults that work with Minikube. So you can see that it started, but it's not doing particularly much. No pods are dying because I haven't marked any. So I'm going to go ahead and I'm going to mark some with my kubectl. I'm going to do kubectl label. I'm going to select deployment yap. It's just a random selector that I did. I'm going to set the end time to midnight because I actually am in London as far as this is concerned. So let me do label enable. Enable true, poof. And if we go back to our PowerfulSeal, and we see that it's actually quite aggressive. So it's basically killing everything, killing one of them every few seconds. And this is a nice occasion to go ahead and take a look at what the graph looks like when things don't go so well. So I'm killing them kind of randomly, so I'm expecting every time I reload the graph to be slightly different. But you can see that this gives you an overview. Well, this is terrible, but it gives you an overview of what's going on with your cluster. All right? So it's pretty easy, and you can get started in 5 minutes, and you can spread already quite a bit of chaos. But let me stop that. The next mode I wanted to talk about is the demo mode. It's one of our latest additions that will probably be deprecating because Hipster went away. But the idea here is that you point PowerfulSeal at Hipster, and it's going to use the metrics to kind of try to figure out what is important on your cluster, what's using CPU, what's using RAM, and then you can go and just let it run and kill things for you a little bit randomly. The next mode is interactive, and this is the first mode that we actually wrote for the seal. It basically gives you like a console where with nice tab completion features, you can go ahead and you can work on things. So it lets you take nodes up and down. You can delete them if you want. You can filter them, all kinds of things. And for the pods, you can list namespaces, deployments, all the kinds of things that you would do manually with kubectl in one place, and you can then go ahead and kill them. I'm not going to demo that. What is probably the most important mode is the autonomous mode. And this is when you've already tested it, you've played it out, kicked the tires, and you have an application that you want to actually see if it survives through some SLAs that you expect it to. So in autonomous mode, PowerfulSeal works with policies. A policy is a simple YAML file that consists of basically 2 arrays of things, of scenarios. One is for nodes and one is for pods. And they both follow the same schema, where you match an initial set of things, then you filter through that, and then you action. So whether these are nodes or pods, you can match them. We're going to go through an example just in a second. You deduplicate that, then you filter out the things that you don't want, and then you action on all the things that are remaining. So to go through the example from the repo, it looks something like this. So for the matchers, the top one is for the pods. You can match by just listing a namespace, listing a deployment, or doing some more funky with labels, kind of freestyle. And for nodes, on the other hand, you can list by things like name, IP, group, availability zone, state, the kind of things that you would expect. Then in the filter phase, you can filter again by the various properties. And you can do things with randomness. So the usual things that you would do would be take a random sample of a particular size or a particular percentage of whatever group it resolved to. And then finally, you just add actions, which for nodes are start, stop, and execute. Execute will come in handy if, for example, you want to test things that don't run on Kubernetes but affect your cluster. So if you wanted to go ahead and, for example, restart your Flannel-D daemon or Docker or whatnot, you can just execute it like this. And for pods, what you do with them is you basically go and kill them. So if you, so when you're running with autonomous mode, it comes with a couple of nice features, like again, it comes with built-in Prometheus metrics so that you can plot things and you can alert on them. And it also comes with a UI that I should actually probably just show you. So if we go ahead and we take an example from the repo, I have copied it here. This is a very minimal config that basically between between 1 and 30 seconds goes ahead, it takes all the pods from the default namespace, takes a random sample of that, and kills it with probability of 77%. So starting that is pretty easy. It's, again, available through the Minikube autonomous mode. If you just start that, these are the options that I specify, and my PowerfulSeal is up. I should be able now, with a little bit of luck, to go through the UI. So the UI provides you with visibility into what's going on. It's going to stream logs here for you about what's going on. In particular, cannot kill container. Interesting. You can start, stop things. I'm going to go ahead and stop it. You can go and play with the configuration. So inside the different scenarios, you can go and tweak the variables, see if that improves it. You can add matchers. You can basically modify all the config that you can do through YAML. And then you can either export it to YAML and go ahead and check it in the repo somewhere, or you can also override it on disk if you happen to be running this locally. And finally, you can also just go ahead and do things in kind of click and play way. So I'm running this with no cloud on Minikube, so this is not available for me to start and stop nodes. But I can go ahead and I can kill nodes. So for example, this one, I don't like it. I'm going to go ahead, I click kill it. And the poor guy just died here. So like I mentioned, metrics available immediately here kind of for free. And yeah, that's how you get started with that. All right. Back here. So the seal has been out for a year now. We have had some pretty amazing feedback from the open source community. We've had people ranging from hedge funds to Fortune 100 companies actually using this. But we would like more. So if any of you happen to be using it or are planning to use it, please do come and share your experience with us. That will help us add the features and help us know how the chaos engineering effort, which way it's going forward. We would love more cloud drivers. Anyone from Google Cloud here? OK, no luck. So I guess no Google Cloud driver for us. And the stars on repo. That's obviously the most important metric of any open source product. So these are the friends that hopefully are going to be for you in the difficult times. I'm just going to wrap it up with a bonus of kind of selling all of this to your manager, because there are like 4 repeated questions that constantly kind of show up. So the first one is, why break it if it actually works, right? In some people's mind. And the answer to that is kind of what we covered, right? If the failure is not an if, it's a when, then it's better to have this when as soon as possible so that the cost of fixing it is smaller. The next one is usually some kind of variant. OK, yeah, cool, but it's production though, so let's not do that. And I found that even in our case, the easiest way was to kind of ease ourselves into that with some more aggressive setup in dev and testing, and then slowly getting ramping up in production. And then usually it's like, oh yeah, but we have enough trouble already. This one is a difficult one, but it can be helped with, OK, let's just do it during the work time when everybody's in and we don't break things when people are asleep. And finally, it's like, OK, we don't have expertise. And with this one, you don't really have this excuse anymore. You just got 2 tools that help you with that, and they are pretty easy to start with. And quite frankly, it's good fun too. So I'm going to wrap it up here. And my conclusion is still, don't worry about the next outage, just make your own, right? Preferably in production, preferably every day. And embrace the inevitable failure, and befriend the seal, and indulge Goldpinger. All right. Thank you very much. That's all I had. Go ahead and grab one for you. If you have any questions, happy to take them. Otherwise, I'll be around if you want to have a chat about it. Yeah, probably best to actually come and chat. I won't hear it from there. Question? Sorry?
Have you run this tool with Kubernetes having a network policies? That's some kind of CNI and you want to implement network policies. So we have to take care of any special policies for this?
So that's for Goldpinger.
That's correct.
Yeah, so obviously if your networking layer doesn't allow them to communicate, you're going to have to add that. So that's going to be dependent on your networking stack. Sorry, the question was, do we need to do anything about policies for Goldpingers to talk to each other? Any other questions?
Does it need to run in privilege mode?
No, it does not need to run in privilege mode. It's actually making an HTTP request. So, sorry, the question was, is it doing actual ping? No, I'm calling it ping, but it's an HTTP request.
Does it support any type of payload size adjustments? I'd be curious about packet loss. Not yet, whether or not we would connect. Maybe see one of our problems that we deal with is we have like maybe an entire sequence where it's packet loss, and we don't have a really good way to connect.
Yep. That's a very good point. So the question is about basically, apart from just a single ping binary, whether I could connect or not, whether it supports any insight into amount of packet loads or bigger payloads. The answer is currently doesn't, but it will be very straightforward to add that, so we should chat.
We use ThousandEyes, and ThousandEyes is really awesome. It's also expensive, and I sort of like test every node, and my color would be very expensive.
Yeah, so that's a very good point. Can you put a GitHub issue for me? Thanks. All right, any other questions? Oh, sorry. All right, back here.
Yeah, so it's kind of building on that. Can you use this to detect, we've been kind of problems with this, detecting the health of node port, virtual service IPs on nodes, rather than just trying to make sure that one node connects to the other on your overall network? A lot of it's just pocket.
So currently, yeah, so sorry, the question is whether it also supports node ports and virtual service IPs. The answer is no, it currently doesn't, but it's obviously a very good idea. So I'll be happy to add that too. Sorry. Yeah, Hipster is deprecated right now, so I'm not sure which way we're going to go. Probably some discussion. We might replace it with the metric server, or we might just deprecate the demo mode. All right. Yeah, so we're basically doing a little overhaul of PowerfulSeal. So currently the setting is that you have the powerful agent kind of outside, and it doesn't require anything to run on any of these nodes. We're working right now on adding a daemon kind of to run on all these nodes. And as part of that, there'll be support for using different runtime containers. And there'll also be support for actually doing kubectl delete pod for people who don't want to give any kind of SSH access. Yeah, sorry, I'll put them right away on the sedge. All right. All right, thank you very much.